I tried to make a loaded coil dipole antenna for 160 meter and ended up having a reasonable SWR at 80 meter. Current configuration is 12.5 meter of wire before coil and 4 meter of wire after the coil. The loading coils are approximately 122.8 microhenries on each side. This is the pattern on Nano VNA showing a minimum SWR of 1.522 at 3.748 MHz, that is slightly above our amateur radio band, which is from 3.5 to 3.7 MHz. A narrow range of 3.4 to 4 MHz was chosen in the Nano VNA to show the finer details. This curve is on a broader range from 1 MHz to 11 MHz. At the trimmed length of the pigtail beyond the coils, there is no resonance near 160 meter, and I do not expect it with a pigtail length of 4 meter. Note that this time the length has been reduced with a shorter length of wire rather than folding back. Only a short length has been folded back. My original calculation was 7.5 meter long pigtail after the loading coil for 160 meter antenna. Even that length of pigtail did not give a good resonance on 160 meter, and I had no option to mount a longer antenna at home. Hence, I have abandoned the plan for a 160 meter antenna. I could not source a ferrite rod to try increasing the inductance of the coil. At a later date, I might try with a different set of coils with higher inductance. One reason for failure on 160 meter could be the low mounting relative to the wavelength, which would increase capacitive coupling to the ground. Smith chart shows the minimum reactive component of impedance at 3.718 MHz of 4.04 ohms. Resistive component is 82.44 ohms. In ideal case with 1:1 SWR, it should have been 50 ohms. Here the corresponding SWR is 1.655. As it is a loaded coil dipole, only a short region of the band has SWR below 2. That is why we say that loaded coil dipole antennas have low bandwidth. Coils have high Q values, meaning that inductance to resistance ratio is high compared to straight wires. I found some disparity between SWR measured in my FT710 radio and that obtained in the Nano VNA. Here SWR is about 1.7 at 3.10 MHz at the lower end of the amateur radio band. After tuning with automatic antenna tuner in FT710, it became 1:1. SWR was nearly 3 at 3.550 MHz before tuning with auto tuner. It became 1:1 with auto tuning. 1:1 SWR was obtained at 3.57 MHz as well with auto tuning. SWR was above 3 at this frequency before auto tuning. Still higher SWR at 3.6 MHz, our local 80 meter net frequency, could also be tuned to 1:1 with auto tuner. If only the noise level was low, I could check into the net tomorrow morning. But I have high noise level here most of the days, and the net control is hardly audible on most days. Finally, I checked propagation from my setup using a CQ call on 3.510 MHz. I was happy to see that my call was picked up at VU2 PTT at 275 km on the reverse beacon network. Though the signal to noise ratio was only 7 decibels, I feel good because the apex of my antenna is only around 5.5 meter, while the ends are at about 3 meter from the ground. These are much below the recommended minimum of quarter wavelength, which will come to 20 meter for 80 meter band. Moreover, one limb of the antenna is shielded by nearby buildings on both sides.